Lunchtime series on LinkedIn and on YouTube. Today, we are speaking about safe AI. There is an ongoing debate about the certification on artificial intelligence in politics and professional cycles. Ideas such as transparency, data protection, and non discrimination are intended to prevent AI from causing great harm, like nuclear physics once did. Typically, legislative proposals and certification proposals focus on risk. Legislation is important, but it does not help today's developer or manager, at least not yet. That's why today we discuss what does a company have to consider when AI is included? That is, components that have been learned. We talked to Dr. Mirko Knaak about this. Mirko is an AI Guild accredited expert in artificial intelligence. At EFL, Mirko leads AI project development and especially safe AI deployment. Mirko, as our audience tunes in, let's look at the European Union proposals to legislate AI risk. What do you make of the distinctions?
Well, the EU separated AI in different categories. The first category is prohibited AI. So that's an AI that is harming people beyond their consciousness or are doing any other harms against their will. So I think for the AI Guild, this is not really a matter because none of us is really interested in developing such an AI. The second one is more important. These are the AIs that are either listed up there in a specific list or that require already know a conformity assessment or being an AI that is in the conformity assessment. And this is a big number of products, so it might be an important part for many of our guild members. The last one that is being regulated is an AI system that requires transparency obligations. So that basically means that if a person interacts with a system, the person should know whether talking to a human or to an AI. What is also a big issue with this proposed regulation is that it applies very harsh penalties, up to 10% of the revenues of the company who is doing it, in case of non-compliance with these rules. And this gives a significant risk, or at least a legal uncertainty for the developer of the AI, because none of the things are really well documented, and there are at the moment no real requirements. So what we need is a hands-on technical discussion what this really means and how can a developer or a company being legally certain to develop the AI.
I think I was muted, sorry. I was saying that, just repeating, I was saying that you're quite right, that the penalties are quite harsh. Like 10% of the revenue is a lot, and the level of uncertainty that we have is quite big yet. Maybe we can take a step back and discuss more generally. For example, Mirko, if my product contains AI, why is it difficult to secure it, to make it safe?
Yeah, AI is basically a software. So you might say in your product, it's a software and you know very well the software assurance process. So the software assurance process is very established. So you might say, okay, it's a done deal. Very, very right. If you look deeper, then software is basically a set of rules, and the software assurance includes a review of these rules, either by peer review or by code review or by splitting into sub-functions, and there are a lot of other things. And now machine learning is different. So then here we do not have any rules designed by humans. The rules have been derived from data by a machine. And to make it even worse, in many cases, such as deep neural networks, these rules are split over many, many neurons and that are not that easy to understand. So what we really need is a assurance process for AI. So maybe starting with an architecture for safety by design. We need to look at the data because data is a key for each machine learning. We need to look to the modeling. We need to look to the platform because in almost all cases, the AI is not going alone. And an AI is a part of a larger system of software where AI is a certain part. So we have to look into the interaction between AI and the other systems. And finally, we need to monitor the AI system during operations. Maybe the domain is being shifted or something else happened. So what we need is such a process for AI.
Okay, so we cannot just test machine learning like we test software. Why is extensive testing not good enough?
The point is that we have something what we call long tail distributions. That means if we have areas in our domain with a low probability of occurrence, then we do not have enough numbers of test points here. However, these points are very often quite relevant because if we have drive recordings, we have maybe hours of hours where nothing particular happens and at least nothing dangerous. So I give you a personal example. I'm riding in Berlin every day with my bike and have been doing it for 10 years or so. And you might say, oh, that's a great thing to drive a bicycle in Berlin every day. What probably is. And nevertheless, I personally didn't have a lot of really full brake experiences to avoid an accident. Despite this long term, it was really rarely the case that I had to do a full brake to prevent accident. And even for my, let's say, human intelligence, it was too less to really train full brake situations. So what I have done, I went to a driver safety training. And for AI, we can do exactly the same. We can bring synthetic data, or especially dedicated data, to overcome this situation.
Okay. So if I understand it right, you are saying that if we don't have that situation, or let's say the specific dangerous situations on real data that we can use to train the models, we could generate those in advance to make the AI learn those situations.
Exactly. This is a point that we dedicatedly train and generate those kind of situations.
That is interesting, and then in that case, it also means that you have to have a lot of understanding of the risks. Let's say the situations that are risky for the application, because then you need to, like, in advance, see what kind of situations could happen and then generate the data for that. Right? For example, like you were saying, the full brake situation, you have to first think that this exists. So it also requires an understanding of the use case, application, and what could be the situations that the AI has to handle.
Of course. So every good process needs to start with a dedicated risk assessment that we see. Okay, what can happen in the worst case, and what are the consequences of these risks? So this would be the starting point for our process in this field, and this would be a necessary part, and then everything derives out of it. So from the risk assessment, we can say, okay, let's start with the data in this field. Let's develop a safety architecture for that, to have a design by safety, for instance, with a double layered approach or something like this, and also invent specific measures based on these risks that you do not have, for instance, an RMSE, what is very popular, but in the community normally. But the RMSE just for mean values. And here we're looking for an extreme values. So if I react in the mean very good, for instance, as my driving, then it doesn't say anything how I would react in this very specific and dangerous situations. So this risk assessment is a base for everything. You're right.
Yeah, cool. And now you mentioned the double layer, for example. So we do have machine learning systems that are non-linear. And can you tell us a little bit more about this non-linearity in the machine learning systems and how the adversarial examples can break, let's say, those systems?
Right. When I said that we have to look whether we have holes in our data where we are trained the system. In many cases in our life, we have a linearity approach that a system reacts in the same way if it's to another situation where it's very close by. This situation doesn't hold in the case of deep neural network and other highly nonlinear systems. And some researchers have shown with adversarial examples, well-designed examples, that maybe a situation close to the situation where a machine is working very well doesn't work anymore. So it's very hard to predict beforehand where it's being working and where it's not working, what puts an even higher pressure to the data that is being used.
Yes, it is. It is. And like given that data and probability, all of that changes the game, what do you think would be a sufficiently safe model?
Yes, I think that point here is that we have to define for the developers again how safe is safe enough. Of course, nobody from us wants to develop an unsafe system or brings a system into the market that harms any people. And the same would appear to, for instance, let's say a cable car operator or constructor in the Austrian Alps. Nobody want to harm people, but these folks have the big advantage. They can develop against some given criteria. They can say, okay, let's we have to take 3 ropes with a diameter of X with a steel of something, and then we are safe. Or we have at least a legal certainty that we have done everything we could do to prevent an accident. Right. So they have the legal certainty. And what I would demand is to have exactly the same thing, exactly the same criteria that our cable car constructor and the Alps have for the AI developer. What do I mean? If I'm looking through this entire process, for instance, in the data phase, how can I measure whether my data set is complete or has a sufficient representativeness? Which safety design approaches are somewhat certified? We have safety supervisors. We have many others. Which ones are the good ones? Yeah. What are good functional measures? I said before, the mean value-based criteria are probably not the ones we are looking for. So we have to look for good measures. And in the end, we have to monitor our system against and shift in the operational domain. For instance, if one is using the car outside the area where it's being designed for, or new things in our streets appear, or something like this. So then, of course, a neural network, for instance, will do something, but not necessarily the right thing. So we have to detect this beforehand. What I really am looking for is to have for the legal certainty for the developers, really significant criteria we can develop against and put all our intellectual capacity against it, that we can say, if we have done this, we are legally safe and certain.
Yes, thank you, Mirko. I mean, you have outlined how to make AI sufficiently safe. There's also a talk about AI being explainable, or that it should be explainable, for example, comprehensive to human. Yeah. How do you see that?
So explainability, if you look to this word, it's explain and ability. So it's the ability of the machine to explain itself. So what is already a pretty vague term if we look to explaining things. So to, for instance, to whom it should be explainable. What is our audience? Should everybody understand it? So should
Yeah.
everybody understand the Big Bang Theory or only astrophysicists? So how
Right.
far should this explainability go? And even for humans, we can be very subjective in our explanation or even manipulative. So knowing this term is pretty vague, and that's why I feel very comfortable with it. Again, when I'm looking for legal certainty, of course, everybody I understand the demand behind it. So
Yes.
if I own let's say a big machine worth 100,000 euros and know the predictive maintenance system comes and say, I have to replace it, even though it's working very well, I would be very happy to get some evidence why it will break in a couple of days or something like this before I throw away a very well working machine. Or if I go to a bank and the bank is saying to me, no, you're not eligible for the loan, I also would be quite happy if the bank could give me any indication why this is a case.
Yes, I think that that's pretty clear. We all understand the motivation why we need AI systems to be explainable, because we as humans, we also don't want to, let's say, be told what to do by the machines. We want to understand what's behind it, right? I think that's human. And I like it very much when you're saying that the term itself, explainability, is vague, because, I mean, who needs to understand it and when it's sufficient? It reminds me of this thing that was also said in this movie, the documentary actually, the Coded Bias, in which it says that okay, we can work or develop code, and we can even make the code open source. Still, doesn't mean that it's explainable, because only people that understand code can start to dig into it. And further, sometimes, like for example, for neural networks, you can look at the code, but if you don't have the data, you will not understand what's happening there, right?
Right.
So yeah, can you tell us a little bit more about the neural networks and if they are comprehensible, interpretable?
As you said before, they are not inherently comprehensible or interpretable. Though the information is being spread over many, sometimes thousands of different neurons, so we cannot really easily interpret what is happening here. So, nevertheless, since the very recent wave of AI, a lot of research has been established and done, and has already achieved some results to make the results interpretable. So
Okay.
there have been developed some things like feature important cases, Shapley values, for instance, to mention the very famous one, that give us as an indication or to which values or which features our network or our system is being looking for. Or we can look to corner cases and others to see even the boundaries where it is switching from one situation or another. So, for instance, going back to our loan decision, we can see to which features in the information I have given to the bank were the most important one for the system to react on. And we can go even further and say where are maybe the thresholds in these values where the system under systems would come to a different decision. And this again might already help me to understand or maybe give me better feeling when I have to live with a decision that I do not getting the loan for my apartment.
Yes. Okay. So there seems to be sufficient interpretability, right? What's the problem then?
the problem is again the vagueness in the term. So first of all, we have still a lot of research ahead of us. And then we come to the second point. For whom should it be interpretable? For everybody, for the human, for the operators, for the AI designers themselves. Mm-hmm. And if it comes really to a regulation, and that's what we're talking about, the AI, the European Union demands explainable AI. So it should be, so will be certainly at one day interpretable for a regulator or for a conformity assessment company such as TÜV or DEKRA or how you name it. So now we're coming again to the point that maybe I'm getting a bit repetitive. What we are missing here is significant criteria to say this level of explainability is sufficient. That's what we expect. And we do not need to go to every bit of our neural network because that's too complex. If we want to see all thresholds, all lines in there, then it's hopeless to get to this point. It doesn't make sense for human either.
Right. Yeah, that's what I was thinking. Even for an AI developer, that wouldn't make sense, I think. Yes. I mean, I like it that you go back to the point that we need specific criteria for the developers because it's not only in one aspect that the criteria needs to be more clear, it's in different aspects. Yeah. And maybe you also, can you share with us what you think about the debates on ethical AI?
I think it's also going in, of course, maybe you can already expect it and guess it what I want to say here. So when we discuss about ethics, so then ethic means that to see whether a decision is principled or moral. And we can first question ourselves whether a system can make moral decisions, because a moral decision needs as a considerable part a will. And at this moment of time, we are pretty far away from having a machine that have a will. But nevertheless, of course, we want machines, and I think everybody in the iGuild is clear that we want to have machines that have, in the end, an ethical outcome or an outcome that fits with the ethical means of the peer group that is being using it.
Yes. Mm-hmm. No, I like this discussion. It also reminds me of the 3 laws of robotics from Isaac Asimov that he was writing in the science fiction. Yeah, I mean, machines don't have yet the will. The thing is that from the machine learning or deep learning systems that we develop, they go or they are connected to somehow a decision-making process, which is made by humans. Yeah? And that is the point that we want this output to be used for ethical decision-making. Yes, you're right. But maybe, how can we make like artificial ethics for AI, maybe for this? Do you have some ideas there?
I think that also here the research has made a significant process over the last years. So, but before we come to the artificial ethics, let's go a bit back to the classical human ethics. So, ethics is just how do I come to a principled decision when I'm in doubt? So, what can I do? First, I can go for the positivistical approach. So let's say moral, what is allowed by law. So I can ask myself, is this what I'm intended to do prohibited by law? So this may help already. If this doesn't help, I can ask myself, and this is the ontological approach, is this principled? So I ask myself whether this was what I'm intended to do is against my principles. So for instance, lying, killing, or something like this. If this also doesn't help, I can go to the next thing, what calls the theological approach. I can look to the consequences. I can ask myself if this what I'm do uh, good for everybody. So what are the consequences of that what I'm doing acceptable for everybody? And then there's a last part that is not that much treated in the academics of ethics. It's, I would say, the case-based approach. But maybe that's the most important for humans.
Okay.
Uh, I'm looking to my peer group, and I'm looking what would my peer group or people I like very much do it in the same situation or have done in the same situation that I am in at this moment.
Okay.
And yeah, and this is already very close to the point where machine learning comes in. I can go from these points to create an artificial ethics. So the first one go to a top-down approach. For instance, I can just do not implement uh, reactions that are against the law or against the principles. Just basically not doing it. Or I can look for the consequences, and the looking for the consequences, it's nothing else than a risk management system. That's what we
Yes.
have learned to do in engineering schools and wherever to see, okay, we have to do a risk management before we do start a development. And this is a very established process. It's nothing new for AI. And now coming to the last part, and that's what we call a bottom-up approach. So the system is basically doing the same what we also do. We learn from our peer group, and our system is learning from the data set. So
Right.
it's nothing else than putting ethical decisions into the data set. So very simple, very easy from the theoretical point of view. From the practical, again, it's of course not that easy. But from the theoretical standpoint, it is feasible, and we can do it, at least in theory.
Yes. Good. Thank you. Thank you, Mirko. So, to sum up, how can we, or what do we need to make AI safe?
So yeah, I have two objectives. One objective is to make AI safe, and therefore we have already a lot of discussions going on. But I also want to have is a legal certainty for the developers. And if the developers are getting a legal certainty, what they really need, given the high penalties that we have seen before, is that we have very clear and very understandable criteria that an engineer can develop against. And that's a point that we should bring in as, let's say, the AI Guild members into the discussion, that we as the experts are contributing to the state what is possible and what is enough, that we say this point is safe enough. I've given some examples where this could be in, but those specific criteria, it's something we do need.
Yes, I agree with that. Thank you. Thank you so much, Mirko, for bringing this so clearly in this discussion. And I just want to say some final words regarding our streaming today. We couldn't broadcast it live due to some technical issues. We do have it now for you. You're watching it, probably you have a lot of questions. So please leave your questions for us in the chat here in the video, and we will catch up on the next broadcasting session that we do live. And we will start by commenting on the observations and questions that you leave here to us. So please leave something there, your comment or a question. Yes. Would you like to say something else, Mirko? I think on my side, I have a lot of things also to think or to process, but yeah, this was really good as an introduction, at least for the topic. Yes, there's a lot more to it for sure. We need to keep the conversation going, like between us as a technical discussion to figure out what could be like more clear or specific criteria.
Yeah, I think that's also my goal of this discussion. So if you would like to discuss with me with the AI Guild about this point, I'm more than happy to do so, because we need to start this discussion to be more specific to become a safe AI.
Great. Thank you. Thank you, Mirko. Bye bye.
Bye bye.